your eyes.
I was just your teacher.
Okay, so let's real quickly kind of get ourselves back into what we were looking at yesterday. And remember, this was Benny the vegetarian. So you go to his burger stand and he rolls the dice to decide what size burger you're going to get. And it's equal probability that you get either side. Ready? Alright, he rolls the dice to look at the size of the bun that you're going to get. And again, it's 50-50 that you get either the 2 or the 7 ounce. And we had groups, remember, we had a group that worked with the burgers, and they got the mean and the standard deviation and the variance for the burgers. We had another group that was doing the buns. They got the mean, they got the standard deviation, they got the variance for the buns. Hopefully you guys you can just be doing these on your calculator, probably the fastest way to get them. And then what we want to do next is we want to do what's called a linear combination, because these are both random variables. So we're going to combine 2 random variables. Because you're not going to go just eat a burger by itself, you're going to put your burger on a bun. So we added the burgers and the buns. Now you know what we didn't talk about, and let's make sure people understand this. Who did the burger plus the buns column? What group did the burger? Okay. Alright, guys, how did you come up with those 4 values for burgers plus buns? What did you have to do to get those 4 numbers? Because there's only 2 numbers for each of them over here, so what did you do to come up with it? So you guys were combined, right? Yeah. What did you guys do? Anybody in group 3 or 4? What did you guys do?
Burgers for the buns.
So you did what? So you did 8 plus 2, that gave you your 10, and then you had to do 8 plus 7, that gave you your 15, and then you do 12 plus 2 and 12 plus 7. Everybody okay with that? You know how they got those 4 values? Okay, now notice here, the probabilities did change, right? Because now you have 4 things and they're all equally likely. So instead of it being a half and a half, it's now a quarter all the way down. Okay? Yeah. All right, and they calculated the mean and the variance and the standard deviation. So guys, again, please make sure that you write this down, because these formulas right here are not on the formula sheet. Okay, and instead of me just telling you these formulas, the intent of this activity is that you look across these columns and just see for yourselves, oh, look, if I want to get the mean of buns or burgers plus buns, I'll just add up the mean for the burgers plus the mean for the buns, because 10 plus 4.5 is 14.5. I can see that, right? I can look at that data and tell that's what's going on, okay? So the mean, and let me write them up here so that when we take this off, we still got them. So the mean of burgers plus buns is just equal to the means of the burgers plus the mean of the buns. It seems reasonable. There's nothing in there that looks suspicious at all to most people. Okay. All right. Now, look at your variance. And there's some round off error here, so we'll just kind of, this is 10.25. The variance, the combined variance is 10.25. Look at your variance here. For the burgers, it was 4. For the buns, it was 6.25. So what did those 2 variances do to get your combined variance? They added. Yeah, 4 plus 6.25. So the variance is added. So if you want to get the combined variance of burger plus bun, you just add up the 2 variances. Add up the variance of the burgers, add up the variance of the bun. Now, when you get down to standard deviation, it starts to break down a little bit, because the combined standard deviation here is 3.2. But if you look at your separate standard deviations, the burger standard deviation is 2, and the bun standard deviation is 2.5, and if you add those together, that should be 4.5, and that's not what that is right there, right? The combined standard deviation is not 4.5, okay? So but if you know what the variance is, right? If you've added your two variances together and you know what your variance is, what do you do to variance to get standard deviation? You take the square root. Well, what's the square root of a number around 10? Isn't it around 3 point something something? Sure enough, okay? That's a key observation that you need to have. Do not add standard deviations together. Add them together at the variance level. Add the variances and then take the standard take the square root to get your standard deviation. So if I want to get the standard deviation of burgers plus buns, I'm going to add together the variances to get the variance and then take the square root. Okay? All right.
You didn't even come up with Vinny the vegetarian yourself?
I did. Oh, no, I didn't. Here's the story. I came up with Molly the measurer myself. The burger thing was actually, I tweaked an activity. I went to a conference, I don't know, 4 or 5 years ago, and the guy was doing something with hot dogs, but it was the same kind of deal. I think he called them Detmer's dogs, because I guess his name was Mr. Detmer. I don't remember what his first name was. So he called them Detmer's dogs. And I thought, well, that's a nice little activity to get them to kind of see the formulas. And then I tweaked it. So Vinny the vegetarian is mine, but the idea of, and I changed his hot dogs into black bean burgers.
What about white bean burgers?
Yeah.
Are they
All right.
ever ask you to write the formula, or do you just need to know it to be able to use it?
You need to know it to be able to use it. Now, we're going to take a little half-page quiz. Maybe we can do it on Monday. We'll do it either Monday or Tuesday. We're all about, no, I told you this yesterday.
We're on Monday though.
Oh, all right, so it'll be Tuesday or Wednesday. It's just going to be on the formulas, and that's one where you have to keep taking it until you get a perfect score on it.
Now,
So these formulas you have to know, because I don't know why, but they're not on the formula sheet, so you have to know them. So we'll take now we can see again. So we'll take 5 minutes in class at the beginning of several days and say, here they are, write down the formulas, and if you miss any, then you're going to do it the next day. I'm going to say write down the formulas until you get them all right, but you got to know them. Then we'll do the same thing again right before the AP exam, because that's in May, right? And what are the chances that we remember all these formulas in 4 or 5 months? So we'll do it again. All right, so now we're getting ready to look at the chomps, right? That's our next thing. All right, so let's see. I'm going to put little subscripts on these so we can track them. So this was burger. This was burger. All right, so now, let's see, now what group did the chomps? Who was doing the chomps? Was that you guys? And you got that for your mean and your variance? So this was the chomp. Now, chomp, remember, that was just my word for bite. Right? I was just using a C just to kind of be silly. So you take a chomp out of the burger. Right? Now to keep it easy, this burger is not on a bun. I didn't want to put 3 random variables on you all at the same time when you're first learning it. So you go up to Vinny's stand, he rolls his dice and he decides what size burger you're going to get. And then he rolls his dice and he decides what size chomp you're going to take out of your burger. All right, and then what group 6 were you guys the one that did the
burger minus
all right, so tell us first how you got those 4 values over there.
So if you have 2 burgers and 2 size burgers, 2 size chomps, you have to put 1 with each of them. So you have to do 8 and 1, 8 and 3, 12 and 1, 12 and 3.
Okay, everybody good? 8 minus 1 is 7, 8 minus 3 is 5, then come do the same thing with 12, 12 minus 1 is 11, 12 minus 3 is 9. okay? Because these are occurring, because these are all equally likely, that means that these are gonna be equally likely, so they're all occurring 1/4 of the time. All right, so now this is burger minus chomp, and this is burger minus chomp. Now something I think surprising happens here. All right, so let's look at this. So what are you gonna say? What's the formula? What's the formula for getting the mean of a difference of two random variables? That your difference here, the mean is an 8. Look at what your first mean was. Look at what your second mean was. What did you do to those individual means to get the difference? You subtracted, right? 10 minus 2 is 8. No surprise there. Let's see. Let me come. All right, I'm over here. So let's see. I'll put it right here. So if you did burger minus chomp, it's gonna be what? The mean of the burger minus the mean of the chomp. All right. Let's look at the variance. All right. Now look at your variance. Your variance here is a 5 for burger minus chomp. Look at the variance for burger. Look at the variance for chomp. Tell me what you do to those variances to get the variance of burger minus chomp. Hang on, Zach, let me get this written up and I'll get your question. What did you do to those variances? You have a 4, a 1, and a 5. Nobody's made a mistake up here. These numbers are all correct. Tell me what you do with those variances to get the variance of burger minus chomp. They add, right? 4 plus 1 is 5. So even though you're subtracting the random variables, the variances still add. The variances still add. Okay, most people find that kind of surprising. They think, okay, well, we're subtracting, let's subtract the variances. Okay, notice that the variances add. So when you're doing the variance for burger minus chomp, it's the variance of burger plus the variance of the chomp. The variances always add. Whether you're adding the random variables or subtracting them, the variances always add. Now the way that I try to make that make sense to me, the way that I try to think, well, how am I going to remember that? What I think is if I'm combining two different distributions together, I think, well, that variance is probably going to be larger than either one of the individual variances, because even if I'm doing it through subtraction, I'm combining information here. I'm combining two distributions, and so I'm thinking, okay, I would kind of suspect that the spread would be a little bit wider than just looking at one of the individuals. Okay, what's going on with standard deviation? Is 2 plus 1, is the standard deviation over here 3? Just add 2 plus 1? Nope. So don't add the standard deviations. Do you subtract the standard deviations? Is 2 minus 1, 1? Is that what we have? Nope. If you know the variance, what do you do to get your standard deviation? You just take the square root of it. Yeah. So the standard deviation for burger minus chomp is just the square root of that variance up there. Okay, Zach, you had your hand up. What were you thinking?
Yeah, what's the difference between the commas and the slashes on the homework?
That's what I was wondering too.
The slashes just mean those three problems go together. They're all talking about the same scenario. So I would do them in that order so that so they just, you know, in one problem they might say, okay, I don't remember, find the mean, and then the next problem they might come in and say, well, find the standard deviation, and then in 43 they might say, come in and interpret this or something. So I just put them all together so that when you were working it, you were working the same, you were doing the same scenario. So that's what that meant. Yeah, because it happened in 6.2.1 and it happens in 6.2.2. Okay? Yeah, that's what that means. I would just do those three with the slashes at the same time.
I was hoping if you like choose one of these three and then do it.
No, it's just they're all the same scenario. So instead of working a problem and then coming back 4 problems later, oh yeah, this was that same test example problem.
Maybe less problems. There's a lot.
I know there's a lot, so that's why today is kind of a work
They take me
day.
like an hour and a half each time.
Did you do it?
Yeah, I don't do it at night. I do it during school.
You do it during school. Let's see, what time does the the bell kind of in here, 8:48? Let's go for 10 more minutes and then we'll stop and I'll give you the rest of the time to be working. There's one more thing that if you look at your sheet from yesterday, let me pull out my sheet from yesterday. There's one more scenario that we want to look at. And let's just divvy it up. We'll divvy it up between even groups and odd groups. How about that? So I'm looking at, so if you got your sheet from yesterday, that'd be a good thing to get out, because this one is probably the confusing one. So let's look at it and pay a little close attention to it. Whoops, don't want to break that. So I'm looking at number 5. So if you have your sheet from yesterday, flip it over. I think it's on the 2nd page. Everybody with me? And it says, what's the difference between 2b and b plus b? And most math students are going to say, what do you mean, what's the difference between 2b and b plus b? They're the same thing, right? B plus b is the same thing as 2b. Well, not in the world of random variables, okay? Not in the world of random variables. So what we're going to do, the last thing we're going to do, I should have left the burger thing up there. We put the burgers back up so we can compare. Let's see, burgers. Here were burgers. Burger. Probability of burgers. 8 and 12. We're getting 0.5. 0.5. We had a mean of burgers was 10. Variance of burgers was 4. Standard deviation of burgers was 2. All right, odd groups. You're going to work on this one. Odd groups are going to do the double burger special. All right, odd groups. Double burger special. All right, double burger means you go up to Vinny.
Bless you.
You go up to Vinny, and he says, okay, I got 2 sizes of burgers. I've either got an 8 or a 12-ounce burger, and he rolls the dice, and let's say it rolls, and he says, okay, I'm giving you an 8-ounce burger, but I'm going to double it, right? I'm going to give you twice the size of whatever I roll, okay? So what are the values for double the burger going to be? If he rolls an 8, what's he going to do to your 8-ounce burger? He's going to double it, right? So 8 doubled is 16. All right? Now, what if he rolls the number to give you a 12-ounce burger? He's going to say, all right, I'm going to give you twice that size, so you're going to get a what? 24. A 24. All right. Now, what's the probability that the 16-ounce burger occurs? 0.5. And we'll let the odd group, hang on, just pay attention for 5 more minutes, or 3 more minutes, hopefully, and then we'll get you odd groups in calculator 3 things. All right, the other deal that he has going on is the burger and burger special. So the other deal that's going on is the burger and the burger special. So that's B plus B. All right, and let's just list it, we'll just list all 4 of them out and then we'll see what we could maybe, all right. So how this is going to work is you go up there, he rolls the dice, let's say he rolls it and you get an 8, and then he rolls it a second time to see what other size he's going to add on to it. Okay, so he doesn't just take the 8 and double it, he actually rolls the dice twice. So let's say he rolls it the first time and he says, okay, will you get an 8-ounce burger? And he rolls it the second time and he says, okay, you get an 8-ounce burger. Again, that could happen. Let's not put the probabilities in yet. All right, what else could happen? He could roll it and say, okay, you get an 8 first, And then he could roll it again and say, okay, what's the other option for the second time other than an 8? He could say, okay, you get a 12. Right? Are those the only things that could happen if he rolls the 8 first? Yeah. All right, so now let's go look and see what happens if he rolls the 12 first. So let's say he rolls the dice the first time and he rolls the number and he says, okay, you get a 12 ounce. What could that be combined with? He rolls it a second time. What's the first possibility that he might get for the second burger? An 8. Or he could roll it once the first time and get a 12, and he could roll it the second time and get a 12. Now, these are all equally likely to occur, right? So let's put 0.25 on each of them. But is there a smoother way to write this distribution? And technically, you could leave it like that. It's not wrong. It's just not the smoothest way to write it. What's the smoothest way to write this thing? Burger plus burger, and probability of burger plus burger. All right, 16. 8 plus 12 is 20. But so is 12 plus 8, so I'm not going to write down 20 again. And 12 plus 12 is 24. All right, what's the probability that you're getting 16 ounces? 0.25. Be careful here. What's the probability that you're getting 20 ounces? It's actually 0.5. And what's the probability that you're getting 24 ounces? It's 0.25. Now, most math people find, as a math person, that just kind of doesn't sit too well with me. Look at the difference in those distributions. There's a difference between burger plus burger. There's a difference between this distribution and just double the burger. So when you're working with random variables, we're just going to have to say that B plus B is not the same thing as 2B. They're different distributions. Okay, so if you're in an odd group, do it real quickly. We want to know the mean, the variance, and the standard deviation for the double burger. If you're in an even group back there, you guys work with this one, and we want to know what the mean, the variance, and the standard deviation is for the burger plus burger. And then we'll be done with the linear combination. So we want to know the 2 B's, and we want to know the burger plus the burgers. And we'll write them up there and figure out our formulas, and then the rest of the time we'll work on homework and do what we need to do to make sure we know this. Where are you, Zach?
I don't think I ever got one of those papers.
You didn't get one? Let's give you one. Anybody else need one from yesterday? Anybody else? That doesn't look like stats, man. That's not a wise choice there, Solomon. You guys already get your mean and your variance and your standard deviation? If you did, go ahead and put them up. Put them up for me.
Pardon me, what's the
211?
the other part? What is it?
211 for double. Which one are you doing? Double burger?
I was throwing some.
Now you guys are now doing double burger. Come on, get with the program here, man. Double burger.
You guys are
Burger
done.
plus burger.
Yeah, you have a whole thing with
We
that.
want to know the mean of double burger.
I can't believe you guys.
We want to know the variance of double burger.
the.
And we want to know the standard deviation of double burger. And then the same thing over here, we want to know the same information for burger plus burger. So we want to know the mean for burger plus burger. We want to know the variance for burger plus burger. And we want to know the standard deviation for burger plus burger. All right, you got them?
Yep.
All righty, odd groups. Tell me what you got for the mean of double burger. What's your mean for 2B? Get it? Odd group. The odd group get double burger? I guess not. We won't put those formulas
We got
up
it.
until we have
We
them.
got
All right,
both of
burger
them.
plus burger. What'd you guys get for burger plus burger?
Mean is 20.
All right, you got a mean of 20. All right, what'd you get for your variance?
7.9975.
Which I'm thinking is probably round off there, and it's probably,
That's what I got.
That mine must have did it wrong.
What'd you guys get? We got
Hold on.
disagree, anybody for
Hold on.
group 6? What'd you guys get for variance? Group 4, you guys working? Everybody doing something else?
Oh, so let me just try it again.
We're gonna check them.
You're gonna try again. All right, double burger people, you got them? For your mean? All right, they're saying double burger people say they got 20 for the mean. What'd you get for your variance? Okay? And what'd you get for your standard deviation? 4. Okay, that looks correct. Okay, that looks correct, and we'll wait on the burger plus
Show me your
burger.
side.
Burger plus burger. Group 6, did you guys get a variance, or what did you get for variance?
And then when I get a one you get a one variable stack.
Okay,
And then,
so you guys got 8 for the variance, which sounds right, and then what'd you get for your standard deviation, how much?
for the standard deviation.
2.8, which sounds about right.
What do you guys
About
see,
right.
radian versus,
So Trent, it sounds like to me what maybe you did, you were calling out 7.99 something. I wonder if you were just, if when you were squaring your standard deviations to look at variance, you just had some round off there and there, because it was close to 8, it's 7.995. All right, let's write down our formulas for these two, and then we'll call it a day. All right. Yeah, Mark was almost gone. Okay, huh? All right, well, yeah, guys, yeah, I'm gonna look at the formula. The formulas for burger plus burger are basically these formulas right here, is just your 2 random variables are the same. So the formula for burger plus burger,
do you know the ending?
the formula for burger plus burger,
Shannon.
I'll just wait till we got everybody's attention. You ready?
It doesn't, yeah, that's my ring.
What if it didn't come off?
Ready?
Gold, don't,
Take some more time.
I won't lose it, it just won't come off.
no.
Hopefully you're doing your homework, and you're kinda eating up the time I was trying to lead you into class to
One
do it.
variable stack.
Okay.
The same, like calculator. You have to.
This Agard?
Uh-huh.
Aye.
One.
Hello?
No sé por qué,
Trying to figure out there. All right, so what we did, guys, what burger plus burger is, it's these formulas right here, it's just your 2 random variables are the same. Instead of adding 2 different random variables, you're just adding the
And it got
same.
stuck on my-
So this should just be
I wore it
mean
like
of
a
burger
and we got
plus
married.
mean of burger. Now that is twice the mean of the burger, right? And look, and you can see that, I mean, your mean over there was 10, and here it's 20. So either 10 plus 10 or 10 times 2. All right, what do you do when you're adding burger plus burger? What do you do at the variance level? You have to do what with the variances? You have to add them. So we're doing the variance of burger plus burger. So that should be the variance of burger plus the variance of burger, and that's just twice the variance of the burger, right? Let's see if that looks like that was happening. So if you take 4, right, 4 plus 4 is gonna give you 8, or 4 doubled is gonna give you 8, right? All right, now, what do you do? Once you know the variance, what do you do to get your standard deviation? You take the square root of it. So once you know your variance, you're gonna take the square root of it. So you're taking the square root of 2 times, and I just write it like that. I mean, if you wanna go in and say, I guess the other thing you could write it is, you could write it as the square root of 2 times the standard deviation. Okay? So the burger plus burger is just a special case of this one. Okay, now, the last set are the ones that get most people. The last set, where you're doing twice the burger, notice that there's only 1 random variable in there. And all you're doing is you're doubling a single random variable. So this is the formulas that we looked at from the linear transformation. Do you remember when we just looked at linear transformations, if you just look at b times x, do you remember what the formula was for b times x? What's the formula for the mean of B times
Judge
F?
you every time you
Because
come.
that's what we're looking at. What is it? It's just B times the original mean. So this one is just gonna be
Yeah.
2 times the original mean. Does that look right over here? Does that look right for double burger? Is it just twice 10? Okay, all right, now what did the variance do? How do you go from 4 to 16? You're multiplying by what? You're multiplying by 4 times what is 16? You're multiplying by 4. What are you doing down here to go from 2 to 4? You're double, well, yeah, you're actually what you're doing is you're doubling it, okay? So what I'm gonna say here is I'm gonna start with the standard deviation, and I'm gonna say, all right, the standard deviation of 2 times B is 2 times the standard deviation of B, and the variance up here for double burger is 2 squared times the variance. So there are my 12 formulas. There are my 12 formulas. Okay, it is a lot. Now this set, I would argue this set, you don't really have to memorize, because if you know these, you can get these, okay? And if you know this, if you know your linear transformation formulas, then you can get these. So I don't generally memorize these two. I memorize these 2 sets. I know these 2 sets, and I tell you what, let's go ahead and put up our linear, we'll put them all up. What are your formula for linear transformation? You remember what your formulas were for your linear transformation? A plus B times mean of X. Standard deviation is next. B times the standard deviation, and then the variance. A plus bx is b squared times the variance. There they all are. 15 of them. Not on the formula sheet. All righty. Get busy on homework. I'm gonna float around and answer questions. Yeah, I'll come back here. Get busy on homework.
So,
Yes.
like the
She's busy.
formulas, like, are in X and Y, Z here.
Yeah, that's fine. Just write them.